आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़ की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Parashar and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़ की आवाज़ की आवाज़।
Indian Statistical Institute is a public university which is recognized as an institute of national importance. It grew out of the statistical laboratory set up by Prashant Chandra Mohananobish in Presidency College, Kolkata. Established in 1931, this unique institution of India is one of the oldest institutions focused on statistics. Primary activities of ISI are research and training of statistics, development of theoretical statistics and its applications in various natural and social sciences. In this podcast, we are happy to present Professor Preeti Parashar, Professor at Physics and Applied Mathematics Unit in Indian Statistical Institute, Kolkata. Let us hear from her own voice about her own academic journey.
I'm Preeti Parashar, a professor at Physics and Applied Mathematics Unit, Indian Statistical Institute, Kolkata. I earned my PhD from Delhi University and was a postdoctoral fellow abroad, mainly in Europe, for many years. I joined the institute in 2002. I'm a theoretical physicist working in the area of quantum information theory, which is at the interface of physics, mathematics, and computer science. Basically, it involves studies about storage and processing of information using the laws of quantum mechanics. As it happens, we are, at this very moment, demonstrating a classical information processing task. Whatever I'm speaking just now is being digitized, that is, getting converted into classical bits, which is a sequence of zeros and ones, and stored into the hard drive, which can then be processed to play and broadcast. Instead of classical bits, quantum bits or qubits for short, which are some special quantum states, are used to store or process or manipulate quantum as well as classical information. The quantum features such as coherence, entanglement, non-locality, etc. allow advantages way beyond what is possible with classical information. For instance, in computation, communication, and security protocols, and even testing the very nature of reality itself.
Professor Parashar explains in detail about the subject itself.
Let me further elaborate on the relevance of quantum information in general. Since information is a fundamental ingredient in the understanding of modern science, while quantum theory is one of the most successful and versatile theories ever formulated, so quantum information, which is an amalgamation of the two, is indeed a very promising field of research. Any process, be it physical, chemical, or biological, is built on this principle of information, that some instructions in the form of signals will be received by some input agents, and then it will be processed to give an output action. Most branches of science deal with objects that follow this mechanism, and hence it will necessarily impact their functioning. Thus, it is applicable for the entire range encompassing the microscopic subatomic scale to the macroscopic astronomical scale. In fact, it is becoming increasingly clear that even the most fundamental questions in cosmology, like formation and evolution of black holes and galaxies, need quantum information theory for their precise assessment. So it is indeed going to revolutionize our day-to-day life. In fact, our present-day technologies will be rendered essentially obsolete in the wake of our ability to process the information at a faster rate, which in turn is expected to severely impact the computation-based fields like cybersecurity. Apart from reducing communicational complexities, quantum information also has many promising advantages like faster computation, unbreachable security, reversible computation, etc. And by harnessing the power of quantum mechanics, it's even perhaps possible to reduce global warming, which is such a big challenge today. So quantum information and computation is definitely going to be an indispensable enterprise. The importance of this subject has been duly recognized in that the 2022 Nobel Prize in Physics has been awarded to 3 scientists for their groundbreaking experiment with entangled photons, establishing the violation of Bell inequalities, which is at the heart of most of the quantum information and computational tasks. Also, this year's Breakthrough Prize in Fundamental Physics has been given to scientists for their foundational work in quantum information.
Professor Preeti Parashar speaks on her own contribution to this particular area of study.
Now about my own research. I work in the domain of quantum resource theories, which pertain to the study of generation, manipulation, and application of quantum resources, where we look for any specific advantage provided by quantum theory for a particular task. Not only identifying a resource, but also its quantification, like how well a resource can perform a given task, is equally important. In fact, there exist several quantum resources, but my research work is mainly focused on various aspects of entanglement, coherence, and also thermodynamics. We have introduced many operationally significant yet computable quantifiers for these resources. Since my work is theoretical in nature, it involves a lot of mathematical and computational tools, ranging from abstract convexity theory to modern optimization techniques like semi-definite programming. It's very important not only for the theoretical relevance, but also for practical purpose, as these quantifiers give an estimation of the cost associated with the task. However, I should emphasize here that the cost is not the real life cost, but in terms of the maximal resource state, which is the standard currency of the theory. Some of my other colleagues in the institute are working on different aspects of quantum information, such as foundations, non-locality, and quantum cryptography also.
Professor speaks about her contemporaries in the country and abroad.
As quantum information is a relatively new and exciting field of research and also of fundamental importance with so much potential, the scientific community and academia from all over the world are deeply interested and actively engaged in research, making it increasingly competitive. Our contemporaries in the West and China are leading in this cutting-edge research, especially in terms of innovative ideas for developing quantum technologies. This has perhaps been partly possible due to the liberal funding they receive. We in India, being a relatively smaller community with limited resources, are also making seminal contributions for the advancement of the field. There are also some research groups in India who are pursuing experimental aspects of quantum information science.
Dr. Parashar is hopeful that this government initiative might boost the Indian industry to involve in this kind of research.
However, the association of quantum technologies with Indian industry is still in its very nascent stage. There are only a few startups as yet, possibly because they entail a very expensive financial venture. Most of the leading groups in the West, besides getting regular grants by academic councils, are also heavily funded by the technology giants like Google, Microsoft, Amazon, etc. But the good news is that the Indian government has timely recognized the need for quantum technology and has recently launched the National Quantum Mission to scale up research and create an innovative ecosystem. This may boost the industry participation, and hopefully we will be able to usher in the state-of-the-art quantum technologies sooner than later. This will also catapult India as one of the global leaders in this cutting-edge research.
We are thankful that Professor Parashar has given us time and spoke on her unique area of studies.